Hey, what you working on? A new YouTube video? Oh, right on. It's about time you made another one of those. What's it about? MIDI? Cool. Are you gonna demo your MIDI piano then? No. Oh. Yeah, Then how are you gonna make a video about MIDI without a MIDI keyboard? I'm gonna use this. Alright. Well, I'll leave you to it then. Alright, see ya. I learned how to play the flute, so I would much rather have a MIDI flute than a MIDI piano. But buying an iwi is not in my budget. I do have one of these though. Maybe I could build an iwi instead. It would certainly be a lot more fun than just going out and buying one. But first, I'm gonna have to figure out how to make this speak MIDI. Now, I can't just plug an Arduino into the computer and expect it to behave like a regular MIDI instrument. It's going to need the right software and the right code before it'll make any noise. First, I'll need the Arduino IDE so I can write and upload code to the Arduino. It can be found at the Arduino website. Next, I'll use an app called Hairless MIDI to take the serial data coming from the Arduino and redirect it to a virtual MIDI instrument. The original Hairless MIDI was a 32-bit application, which doesn't work so well in 64-bit operating systems. Fortunately, a kind soul has made a 64-bit fork on GitHub with downloads available for Mac, Linux, and Windows. Third, either Loop MIDI for Windows or Audio MIDI Setup for Mac OS to create a virtual MIDI instrument that a synthesizer or DAW will recognize. Fedora Linux creates a virtual instrument automatically, so points to Linux, I guess. And finally, a synthesizer to output sound. I'll be using Dext, a software version of the legendary Yamaha DX7, but any DAW will work. You can even use VCV Rack if you want to go modular. Now, how this setup works is the Arduino spits out serial data into Hairless MIDI, which translates it into regular MIDI data and sends that to the virtual instrument created by Loop MIDI or Audio MIDI Setup. Finally, the synthesizer receives the MIDI data from the virtual instrument and outputs it as sound. It's a cumbersome process that I could avoid if I used an Arduino with native USB. But since I don't have one of those, this is how it's going to be. To set up a virtual instrument on the Mac, open up the Audio MIDI Setup app in the Utilities folder inside the Applications folder. Go up here to Window and select Show MIDI Studio. A new window opens up with some squares in it. Double-click on the grayed out red one called IAC driver. And I'm going to go ahead and rename mine to Miduino Uno. Technically, I'm using a Diegimilla, but Miduino Uno rolls off the tongue better. Make sure Device is Online is checked. Click Apply and go ahead and close out of Audio MIDI Setup. In Windows, open up Loop MIDI. Enter Miduino Uno in the text box here, then click this tiny plus button, and that's it. Then, in the synthesizer of your choice, make sure the Miduino Uno virtual instrument is active. Finally, in Hairless MIDI, select the Arduino in the serial port pop-up. Don't turn on the serial to MIDI bridge just yet. Then in the MIDI out pop-up, select the Miduino Uno. MIDI stands for Musical Instrument Digital Interface. It's been around for over 40 years and it's still on version 1.0, though there is a 2.0 coming. Eventually. I think. To play a note, MIDI needs 3 bytes of information. The first byte sends a command, and the next 2 bytes are data. So to send a note on message, I need the command for note on, the MIDI note number I want to play, from 0 to 127, and the velocity of the note, also from 0 to 127. That's just how loud the note will be. So with that information, it's time to open up the Arduino IDE and write my first script. First, I'm going to start the serial interface with the serial begin. The native baud rate for MIDI is 31250, but I'm going to use 9600 instead. It'll be fine. Then inside the loop, I'll start sending serial data. First, the note on command, 144, then a 60 for middle C, and 127 for maximum velocity. Play for 1/4 of a second with a delay of 250 milliseconds. Then send the note off command of 128, the note I want turned off, middle C, and a velocity of 0. Then wait 1 second and repeat. Upload the code. And now I'm ready to open up Hairless MIDI and Dext. Now I can turn on the serial MIDI bridge. If all goes well and I haven't messed up any settings in the utility apps, then I should start hearing a repeating middle C in Dext. And there it is. I have now successfully used an Arduino to send MIDI to a synthesizer. Exciting. One note, repeating, endlessly. Oh. Time to make a human interface device. I'm going to keep it simple and start with a single button. I'll connect ground and 5 volts from the Arduino to a breadboard and hook up one side of a single tact switch to ground and the other to pin 2. Then reconnect the Arduino. First, I'll create some button state variables. Then read the button state and invert the result, since the input pull-up will make the button go low when active. Now I need a conditional so that the Arduino will only send data when the button changes from off to on or on to off. And if it's on, start playing the note. And if it's off, stop playing the note. Finally, set the previous button state to the current button state. Switch over to Hairless MIDI and Dext. Turn on the bridge and cool. Now I can be the one to play the same middle C endlessly. Okay, Time to make a dedicated send MIDI function so I don't have to keep writing serial.write multiple times in the code. I need a command byte, a data1 byte, and a data2 byte. Let's make a little room here. Then I can just copy and paste and change this to command, data1 and data2. Then I can go up here and change all of this to my custom send MIDI function. Also, I'll get rid of these delays. Let's see, anything else? Yes. I'll add some constants for the note on, note off, and velocity bytes. And I'll write these in hexadecimal just to be extra confusing. Oh, I'll make an array of the pins, though for now I'll still only be using pin 2. Make a variable for the note. And then here I'm going to change this to a loop so it will automatically set the pin mode for whatever pins I put up in that the pins array. Oh, num pins. I'll define that in just a second. The pins I, then go back up and define num pins as size of the pins. Go ahead and upload. Go to the synth, turn on the bridge, and there it is. It's a little glitchy, probably because I haven't debounced the button yet. The standard debounce function on the Arduino website works, but I found it's kind of clunky for my needs. So after a bit of internet searching, I found an alternative one that uses a bit shift left on a static variable.
Wait. What?
Okay, so there's this thing called a shift register that basically takes whatever input it sees and shifts it over by 1 with every clock pulse. Here's a demo of one working in the Circuits.js1 simulator using a bunch of D latches. Now let's say if I want a signal to go high and I want to make sure there aren't any hiccups in my button, I can have my program wait until all 8 signals are high before it sends the actual high signal. How that works in Arduino code is by shifting a 1 to the left with every loop. Once all 8 bits in the byte are 1s, then the button is considered properly debounced and the signal will go high. So, to create a debounce function, I'll need to change this array from an int to a uint8_t, then change the button state variables to arrays with the number of pins being used. Okay. Then I'll return a true or a false with the debounce function. And I'll have it debounce the index value of the current loop. So make a static uint8 array called state with the number of pins. Static just means it'll remember the value after every loop. Then for each index of state, shift a 1 to the left, logical ORed with the inverse digital read of the pins at index. Then delay 1 millisecond. And return a high for that button index if all 8 bits are 1s, or a low if any of them are 0. So inside the loop, I'll make a for loop with the number of pins and then button state I for all of these and prev state I. And upload. Turn the bridge on. Cool. That sounds considerably less glitchy. Now it's time to make something vaguely musical. I'll define the tonic as middle C. And I'll make an array of intervals for my favorite scale, the double harmonic. 1, 3, 1, 2, 1, 3, 1. I'll need an integer array to hold the 8 MIDI note values of the scale. And of course, I'll need a variable for the note. Then, if the button state is high, choose a random note from the scale. Random 8. Change the 60 to note. Oh, and maybe change these to the constants that I defined earlier. Note on, velocity, note off, set this to note, and that can stay 0. Then, up in the setup, make a loop to get the MIDI note values of the scale. So note will be note plus double harmonic index J, and then put the note into the scale. Oh, and make sure the root of the scale is set to the tonic. Upload and turn on the bridge. Okay, that's working. But I think I need a little tiny delay so the notes don't overlap each other quite so much. 5 milliseconds ought to do it. Upload again. There, musicality. This is a good start, but it's still a long way from being an iwi. For that, I'll need some more buttons and an air pressure sensor. But I'll save that for the next video. For now, I'll leave you with some footage from 13 years ago of me playing the flute for my cat.